Hi, in the comments to my last video I got a few requests to explain my Python script that analyzes the Spotify data. So that's what we're gonna do in this video. Enjoy! Let's start with checking out the Spotify data. This directory, my data, is all I get from Spotify, and you can have it too. Just log into spotify.com, go into your account overview and look for privacy settings. Once you're there, find the part that says download your data and follow the listed steps. After a few days, your data will be ready to download. Okay, so this Spotify directory contains multiple files, but we're only interested in the streaming history. You see these two files, streaming history 0.json and streaming history 1.json. That's all the data we need, so let's take a look into it. Theme streaming history 0.json. This file is one enormous but very primitive JSON. It contains a list of stream information records. Each of these dictionaries, and that's one dictionary, describes one stream with 4 fields: end time, or the time at which the stream ended, artist name, track name, which is that title, and milliseconds played, which is the length of this particular stream, not the song, but the stream, because you didn't necessarily listen to all length of the song. Having all these metrics, we can actually get quite a lot of information from this data. So let's get into it. It's time to code something already. This tutorial is all about Python and Spotify stats, so let's create Spotistat directory to split the code from data, of course, and Spotistat .py file inside it. First we need to import some modules. Pandas, sys and JSON is all we need now. So import pandas spd, import sys, import JSON. Let me explain. Pandas does all the database editing magic. Sys module will give us access to command line arguments passed to the script, and JSON module will interpret the streaming history.json files as JSON structures. Let's call something now. If name equals main. This statement makes sure that the code below it will be executed only if the script is called directly. And now we need to pass the paths to streaming history files to the script. So this list sysargv must be at least 2 fields long. The length of it must be at least 2, because there's always the name of the script in this list. Okay, so it's, yeah, that's it. And now all these paths will be sent to main function. Okay, sys.argv. Yeah, this should work. It does. Okay, so main function takes only one argument, a list. I'll call it stream file list. Now let's check if we got the right list. Stream file list. Okay, cd spotistat, and we got our file here, and let's run it. Spotistat, let's also give it some context. My data streaming history.0json, and the second file, my data streaming 1 JSON. Okay, yeah, we got it. it works fine. Right now, all we have is a list of paths to streaming history files, and what we want is the pandas data frame. File to df function will convert list of paths into one data frame. Okay, def file to df, and it will take one argument, stream file list as well. Okay, now dfs set to list. This list will store data frames which later will be concatenated into one data frame. Now it's time to open all the files from stream file list, read them and parse as JSONs. This can be done with a simple for loop and with instruction. So for fname in stream file list, with open fname sf. Now that we have the file descriptor, let's read its content and parse it as JSON with the JSON loads function. So JSON loads fread, okay. And next step is conversion from JSON to pandas data frame. So this will be done with pd JSON normalize, okay. And we want to set this statement to df from JSON, data frame from JSON, okay. The last step of this for loop is to append df from JSON to dfs list, df from JSON, okay. And at the end of this function, all we need to do is to get the data frame, which is the result of concatenation of the frames from the fs. So let's pd.concat dfs and no sorting. Okay, return df. Now that we have it, let's check out the result. df set to file to df stream file list and print df. I think it's all fine. Let's check it out. Yeah, that's perfect. Next step is to actually do some work with the data. The first thing I came up with was Spotify listening time per day. It's very simple. All we need to do is group the milliseconds field by days and then sum it all up. Voila! Okay, let's write some code. So I'll call this function listen time per day, and it will take only one argument, df for data frame. So let's create it here. Oh, okay. And the first thing to do is to convert this end time field from string to pandas data time. Date time. Right. It will be set to this original end time column. And now we can convert it with pd date time. And again, let's take this end time column. Right. Next step is to drop the information about specific hour. No hours. And once again, this will be set to the original end time column. We need to preserve the information about type, which is the data time, date time. And now let's take this original end time column and change its format with this special formatter, strf time. So it will only contain information about the year, month, and day, and nothing more than that. Okay, at the end we only need end time and milliseconds played field. So I'll make a new data frame here. df time set to df end time and ms played. Right. Now it's time to group data frame df time data frame by end time field and sum the milliseconds played field. So let's group it. It will be set to a new variable, df time sum. And now we need to group by column end time as index set to false, and let's aggregate it by milliseconds played, ms played. Also, we need to sum up these milliseconds. Yeah, I've forgotten about the dots here. Okay, right. We also need to convert milliseconds to something more readable, like hours. That's what this line will be for. I want to create new column here called hours played. And now let's df time sum. Let's take the ms played column and divide it by 1000 for 1000 milliseconds in a second, then by 60 actually, and 60 again. Yeah, that's it. I actually think we can put this conversion into a function, so let's call this function ms to hr for hours, of course. And let's create it here. Def ms to hr will take only one argument, msval. So return msval divided by this. Okay, and now let's return our df time sum to the well, here df to set. Okay, let's print it and see what's going on. Oh, group by, my bad. It's group by. Yeah, so now we see they, ms played, and well, time, this exact same time but in hours. As you see, this first day, 28th of March, there wasn't really much time spent on Spotify, and that's correct because only 2 songs were played at that day. So not much, and it's not much either. But here on 2nd April, it's already 8 hours. It's always better to see the data, so let's plot it using Matplotlib. First we need to import Matplotlib, import Matplotlib pyplot as plt, and this seaborn module, which makes things look prettier. Seaborn. Don't forget to set seaborn with seaborn set call. Seaborn set call. Okay, we will also need mdates and cbook from Matplotlib. Dates as mdates and cbook as cbook. Alright, I'll put a plot flag to listen time per day and set it to false by default. And this flag will enable the part of this function, well, responsible for plotting the plot. So if plot. Now let's create a new figure and axis. Fig ax set to plt subplots with just one subplot and make it a bar chart from end time column and hours played column. And the data is of course the df time sum data frame. Okay, next step is to set the titles, just one title actually. Set title to listening time to Spotify streams per day in 2020 and 2021. Alright. Also, I like to set the Y label. Okay, to hours. That's an age. Okay, and the next part is responsible for setting the major ticks every month. So let's create new variable, fmt month, and now let's use the mdates module, month locator with interval of 1. That's just 1 month. 1 month of interval. And put the setting to our axis. So x-axis set major locator to fmt month. Right. And the last step is of course to turn the grid on. So let's set axis grid to true. Okay, there's also one part I forgot about, which is responsible for making the dates on axis diagonal, and it will make things easier to read. So let's fig auto fmt xdate. Alright, well, of course we can't forget about showing this plot, so let's plt.show. I think it's all alright, so let's run it. Oh, I think, okay, right now. Okay, yeah, we have this plot flag, so let's set it to true. And we have our data here. And in my example, as I said already in the last video, we can clearly see that there's there is just a huge hole in July and August. Yeah. So now you've seen the basic use of Pandas module and Matplotlib, and it's very similar in the rest of my code as in this listen time per day example. So I'm not going to go line by line with the rest of my code, I'll just command it so you will know what's going on. But the real work belongs to you. I don't have this much time, it's really time consuming, you know? So yeah, let me go with you through the rest of my code. This next function, average weekday load, will give us information on how much do we listen to Spotify each day of the week. So let's take a look into it. First, it's just like in the previous example, converting endtime string to datetime format. That's getting rid of hours, just like in the previous example. Grouping by date, we know this as well, but here's something new. Fill in missing days, fill them with 0 milliseconds played. Do you remember those empty days with really no listen time in the previous plot? In August and July there were holes, just holes because no time was recorded. We need to fill those days with 0. If no time was recorded, then it doesn't exist in our database, and to make those calculations real, we need to create new records in our database for those empty days and just fill them with 0 value. That's what these two lines do. And here's the part where we will actually split our whole data into the 7 days of the week. So we need this list because we don't yet know, well, our data doesn't know that it's divided into days and it doesn't know how the days are called. So we need this. Next part, here we create a new column, actually 2 of them. And this part, what we do here, we convert the column date that we created in this line. We convert it to name of the day. So right now the data actually knows what name of the day it is. But we need to create its copy. You'll see why in a second. Well, we also interpret it as a special type, date types. yeah, that this type is created here from our list of days. Okay, and now here's where the magic happens. It's the actual grouping by days. So as you see, the data is grouped by weekday, by these days, and then this second column does the counting, because you can't really count the column by which the data is grouped. This is why we needed to create the second copy of weekday. Okay, so this counts amount of days, like amounts of Mondays, Tuesdays, Wednesdays, etc. This column counts or sums up the number of these days that appeared in our data, and this column sums the time of all Sundays or maybe of all Fridays, etc. And also we actually want to change these names of our columns. I was wrong. This end time, what it does, it will count number of records per one day. So what it is counting the number of streams in some day, like number of streams per Monday or Tuesday. This part is how many days appeared with that particular name. Okay, and here's some other stuff, which is, well, this is not very complicated. What it does, it counts the hours played from milliseconds played using our function ms2hour. This is the average hours played, so we will take sum of hours per day and then we divide it by number of this particular days. Next is number of streams, average number of streams. So once again, it takes number of streams per day and divides it by a number of this particular day. And the last one is stream length average. So this last part, this is once again length of the streams, average length of streams in minutes. So it will say how long was an average stream in some day. So we take the ms played and we divide it by number of streams converted to ms to hr. I don't really like it. I think this was supposed to be here, ms to hr. Okay, this makes much more sense to me. Yeah, and here the data is printed, and this whole thing, this part is just about creating a new plot, a new figure. So let's start with dropping the columns, because I don't know why, we just don't really need milliseconds played, hour played, day count and number of streams. We're not going to use it. Here we create a new figure and add 3 subplots. As you see, it's 2, 3, 1. It means that there will be 2 rows and 3 columns of plots. So here we create 1 row with 3 plots. And this axis, AX axis equal, means that we want this axis to be equal in some way. And this is necessary because we are creating here the pie chart. So this particular part is creating pie chart from hours played average with a special kind of label. This is formatting of a float number. So 1 place before a decimal point and 2 numbers after the decimal point. Okay, and in the title, average stream time per day. Very similar in the next part, but this time it takes average number of streams, yeah, as it says here. And the last part is taking the average stream length per day. Yes, that's what I explained here. Okay, but here we have the second row of this chart, and this time it's bar charts. And once again we take charts number 4, 5, 6, because, well, while creating those charts, by telling the Matplotlib that you want 2 rows and 3 columns, it will create a special kind of array with exactly 2 rows and 3 columns. And then it will number those places 1, 2, 3, 4, 5, 6. So the upper row takes 1, 2, 3, and the lower row will take 4, 5, and 6 numbered places. Okay, and here it's time to create a bar chart on the first axis from average hours played. And I'll just put a label here with hours. Next one is number of average number of streams. And the third one is length in minutes in average per day. So it's just a different way to show the same data as in the pie charts. But sometimes it's just better to see it on two different ways. And this last part, as we saw in the previous example, this part is responsible for making this whole chart easier to read, in particular the x-axis descriptions. So they will be diagonal and not straight, but diagonal. And here, well, we don't need this because this was already printed here. Okay, let's see what it gives us. Only this function is enabled, so let's see what's the result of it. And as you see, there are 6 charts. As I said, 2 rows. Yes, 2 rows. Oh fuck. This one's broken. Okay, for some reason this one's broken. I don't really know why right now. But anyway, we got 6 charts. Well, 1, 2, 3, 4, 5, 6. That's the numbering I told you before about. Let's take a look in the code. Maybe I did forget about something. Maybe actually that's the reason why. MS to HR. Let's take a look now. Yeah, that's very mysterious, but I did repair it. Okay. It's time now for the next function. So let's comment this one and uncomment the top artists. So what this function will give us is the top artists. How many artists do we want? I guess 30 isn't good number, so that's what I picked up. So let's jump into it. It's a little different than before because we don't really need any kind of date this time. So we will only work on counting how many records appeared for an artist. So let's start with grouping by an artist. Then we will count how many records appeared. This is what this end time does here. Counting the number of records. And summing up the milliseconds played. So let's sum all the time an artist was played. And here's the renaming of these columns. End time to number of streams and milliseconds to stream time milliseconds. So it's just a little more readable. Well, here is the conversion from milliseconds to hours. And a new column appears, stream time hours. And to get the top 30 artists, we need to sort it descending. Not ascending, but descending. That's why this says false. This part only takes head top records of this particular data frame. Yeah, top 30 head records. Okay, now let's jump into the plotting part. This time, let's just create a figure, add one subplot. This part is interesting because it's a cloned axis. The data will appear at this very same subplot, but we can actually put different data there. That's what this twin X does. Okay, let's put the grid. Oh no, it says false, so it actually hides the grid. And this is interesting because we want to create a bar chart here, as you see. And this width is the width of a single bar line. Yeah, we also need to create a new array with indexes from 0 to 30. As you see, it's np arrange. For that, I also had to import a new module, numpy as np. This is very popular math module in Python, so use it a lot. It's very good. I like it a lot. And yeah, this is a list from 0 to df top, so it's probably from 0 to 30 in our case. Here we create the bar chart, so this is the x-axis, 0 to 30, and this is the y-axis, number of streams, and that's the width of one bar, and it will be a red color, and that's the label, number of streams. And again, a very similar thing, but this time we actually want to make the width a little different. We want to move our chart a little to the right, and this will make this happen, adding width to index. So let's just say that the first value of index is 0, so if we add 0.27 to it, then it's already 0.27, and if the previous bar ended on 0.27, then this new one will start at the place where the previous one ended. So that's why this will work. And again, the color is blue, B for blue, and a different label, stream time hours. Okay, this is legend placement, upper right, so yeah, upper right, nothing to explain here. Set X ticks, these are those very small lines on the X axis that will indicate, well, you'll see yourself. And this is labels of those X ticks. Well, we want to put an artist name there, so that's why it takes artist name. Again, title, top artists sorted by number of streams. In our case, it's 30. By default 10, but we chose 30 when calling this function. Do you know what f strings are? If not, then check it out. It's very nice and simple to use. Okay, next line is setting the y label. Again, the label for the twin x axis. One axis will be number of streams, that's the red one, and the blue chart will be stream time with hours. And this, again, figure auto fmt x date will put the X description diagonal. So let's see what this gives us. Yeah, is it right? Yeah, that's right. Let's run our script. And as you see, that's exactly what I told you. The red one is number of streams, the blue one is stream time in hours, and it's one next to another. This is why we needed to put width to 0.27. Yeah, and this is what this FMT auto does. It puts artist labels diagonal. Next part is top tracks. Again, as many tracks as we want. In our case, it's top 30 tracks. Let's see what we got here. Again, very similar to the previous example, grouping by track name and artist name. This is just because a few artists may create track name with the same name. This is why I wanted them to be treated as one together, track name and artist name. Remember, indexing true isn't always necessary. In our case, it's just convenient to have false here. Next, let's count the records, end time, number of records per particular track name is counted and summed up with Matplotlib. Of course, it's convenient to rename those columns, end time to number of streams and Matplotlib to stream time milliseconds. Next is creating a new column. Let's create stream time hours from stream time milliseconds. We know this already. And again, sorting with descending order. This is taking first top records, in our case top 30 songs, and this is creating a new column with full name of particular song, so it contains artist name and track name divided with semicolon dash whatever. And now it's time to plot it. Again, it's very similar to the previous example, creating new subplot, just one subplot, twin x, a twin of this original axis, no grid because we don't really need it on bar chart, with 0.27, a list of from 0 to top to length of our database, and next let's create the bar chart. So this again is red and its number of streams, and the second bar chart is blue and the title is stream time in hours. Legend to upper right, we know this already, y label to stream time and diagonal description. So let's see. Yeah, that's correct. Let's save it and run it. And once again, that's what I expected. And as I said in my previous video, MGMT is the first one here. Yeah, top 30 songs sorted by number of streams. You know this already, I made an analysis in the previous video. Let's check out the next part, that's top artist history. And I like this function a lot. It's a little different view of this data, so let's check it out. It's here. What this function will do, it will just plot the history of playing a particular artist, actually top X artist with X-axis as a time axis. So first get only those artists that are in given DF top 10 data frame, because as you see here, we pass this first DF top 10 data frame that we got from top artists. So this data frame will only contain information about, in our case, top 30 artists, but here we only take first 5, so top 5 artists. And this is passed to this top artist history function. So this line will actually it will take all the records from data frame, from the original data frame, that contain information about our top artists, in our case top 5 artists. Next part is change date time format to only date. We know this already, so I'll skip it. That's it. Apparently we can do this in one line and not two. Next line is grouping by artist name and date. Yeah, that's because we want to print the time history this time. It will tell us how many times did we play this particular artist in this particular day. Okay, and renaming the end time column to number of streams. It's time to plot it. Let's create one subplot, and now we will plot all the artists in our DF top 10 data frame. We take all records that are related to this artist here. That's what it does. If DF top artist equals artist, then take it and put it to new variable df tmp, temporary. Okay, and now it's time to plot it. So this date is just the x-axis. This is the y-axis, number of streams per day. Does it make sense? It does to me. If we'll see an artist played in particular day, then there will appear this O dot. If not, then we'll just see two dots being connected with a line. An artist, that's a label because we want to see what the artist name is. Put a legend. After all artists are plotted, then put a legend on the chart. Set a new title, top X artist streaming history, and set a new label, number of streams. So let's save it and check it out. Oh, number DF. Okay, of course we have to see these, but I don't want to plot this previous one. So wait, does it have information about plot information? Plot true. Let's put it to false because why not? Okay. Yeah, top 5 artist streaming history. Okay. Yeah, as you see, these are the points where some streaming of this artist actually happened. 1 point, 2nd point, 3rd, connected by lines. Let's go to the next part. So we can comment these two. And because this function top artists most days only uses the original data frame, and I actually think I didn't include any plotting in this function, so no, we have plotting here. That's even better. This function will plot the artist by number of days this artist was listened to. A little different view at this data again. Let's start with converting end time to data time format, the pandas format. Change data time format to only days. So again, we remove the hours. We only leave year, month, and day. This time we drop columns milliseconds played, end time, and track name because we don't need them. We already have new column with date only. Oh, that's an interesting thing. Previously, we had to put a new variable here to get those changes, but if you specify in place to true, you actually don't need to do that because those changes are done in place in this original data frame. Here again, we drop the duplicates. That's because here an artist could be played several times a day, and we only want to see how many days did it appear. And that's why we drop all the duplicates. So we just want to see one record per day if an artist was played this particular day. Okay, so now it's time to group this data frame by artist name, count the dates, so count how many days was this artist listened to, and rename date to days. Yeah, number of days. This could be number of days. I think this makes more sense. And now again, let's sort values descending by number of days. Again, we use this in place thing. Sometimes it's easier. And we take head top artist. So in our case, it's top 30 artists. And then it's time to plot it. Again, I'll have to change it here to number of days. This time we take width of 0.7. Let's create a figure with one subplot, set title to top 30 artists streaming history by recurring days, and set Y label to number of days, and create a bar chart with artist name and a number of days. And this width will be the width of one particular bar. And okay, this is just put in the artist name labels diagonal. Yeah, let's see that. I'm quite interested myself because I don't think I saw that before. Aha. Okay, very simple. Still metronome is the best. Over 20 days. Yeah, over 20 recurring days, but MGMT is very high as well, and the black keys. Yeah, I think that's it. I showed you my whole code, so you can use it in whatever way you want. You know how to create those data analysis function yourself, so use it in the way you want, be free and have fun with your Spotify data. And subscribe, because I really want to get to 1000 subscribers in any time. I mean, I want to achieve it someday, and this will give me a lot of opportunities. So support me in this way. This will help me a lot. Yeah, have fun. Bye.